Okay, so hello and welcome again to Engineering Physics, and for today's video, we would now be discussing about a sample problem or a couple of sample problems in uniformly accelerated rectilinear motion. Okay, so when we say rectilinear motion, so these are to be the motion that is to be acting along a straight line. So that is for rectilinear motion. But what about for linear motion? So suppose that we would now be dropping this word here. So for example, we are only to talk about linear motion. So your linear motion is to be your motion which is to be acting along a line. So it does not necessarily mean that it is to be a straight line as long as it is to be a line. So your linear motion can also act on a curved line. But as for your rectilinear motion, they can only act along a straight line. So that is for rectilinear motion. But what does uniformly accelerated motion mean? So for your uniformly accelerated motion, these are to be the motion that has an acceleration equal to a constant. So what that means is that the acceleration is to be the same throughout that particular motion. And with that, guys, so when you say that your acceleration is to be constant, it means that your velocity is to be changing at a constant rate. So if you would now be graphing your velocity versus your time, your velocity must change at a constant rate. It means that its change must be along a straight line. So there. Okay, so with that, guys, we can now make use of any of these formulas if you are now solving for uniformly accelerated motion. So once again, for your typical uniformly accelerated motion problem, you can make use of these formulas, but of course, the formulas are not limited to these ones right here. So these are just for the typical problems. Okay, so in this video, we will now be dividing it into two. So we would be having a simple problem, and we would now be having, let's say, a much more advanced problem as compared with the first problem. Okay, so for our first problem, so it is said here that a ball rolled on a flat surface with an initial velocity of 4 meters per second. So for the first sub-question, what is now the ball's acceleration if it was found 20 meters away from its starting position after 6 seconds? So for us to better visualize the problem, so I will now be drawing the figure here. So suppose that this is now to be your ball, and let's say that it is now to be traveling along this line. Okay, so it is said here that the initial velocity, so your initial velocity is actually VI. So your VI is now to be equal to 4 meters per second. Okay, so according to the problem, what is now to be the ball's acceleration if it was found 20 meters away from its starting position after 6 seconds? So with that, let's say that this is now to be your 20-meter mark. So let's say that is now to be your 20-meter mark. So let's say that is now to be measured 20 meters. And with that, this ball would now move to this location after 20 meters after 6 seconds. I mean, 20 meters after 6 seconds, I'm sorry. Okay, so with that, we can now make use of these formulas here, whichever is to be applicable. So in this case, since we are to determine the acceleration, so acceleration, with that, so once again, we would now be determining the acceleration. We can now make use of these formulas here. Okay, so can we make use of the first equation? So the short answer, we cannot make use of this because if we are to solve for the value of the acceleration, so your variable acceleration is not given in this formula. But what about for this? So as you can see, we have the value for acceleration here. However, we do not have the value of our final velocity because it is not given in the problem. Okay, but what about for this particular equation here? So we already have the value of x. We already have the value of initial velocity as given in the problem. We also have the value of your time. And the one unknown is to be the value of our acceleration. So with that, one equation, one unknown. So I would just be rewriting this equation here to our next slide. So that is now to be equal to, so x is equal to the initial velocity times time plus the acceleration times the time squared divided by 2. So once again, this is basically this equation. Substituting known values, so for our x, so that is now to be equal to 20 meters. So this is to be equal to VI, which is to be 4 meters per second, times time, and our time here is to be 6 seconds, so 6. So plus acceleration, and our acceleration is to be the one unknown, times time squared, then that is not to be 6 seconds squared divided by 2. Okay, so we can either make use of the shift solve parameter or the shift solve feature of our calculator, or better yet, if we would now be solving for this algebraically. So with that, I'm rearranging our equation here. So this is now to be equal to, so A times 6 squared divided by 2 is equal to 20 meters minus 4 times 6. So for us to isolate this A here, so A is now to be equal to, so 2 times 20 minus 4 times 6 divided by 6 squared. So basic algebra. Okay, so with that, our answer is now to be equal to, so 2 times 20 minus 4 times 6 divided by 6 squared. So our answer here is now to be equal to negative 0.2222 meters per second squared. So with that, so let us confirm for this answer using shift solve. So 20 is equal to, so 4 times 6 plus alpha x times 6 squared divided by 2. So suppose that your alpha x is now to be the value for your acceleration. So shift solve equals, so that is now once again negative 0.22222 meters per second squared. Okay, so what does this negative symbol here indicate? So that indicates that your ball is actually decelerating. So by decelerating, it means that it is actually slowing down. So if it is to be slowing down, so once again, that is to be your deceleration. Because if you would be having a positive acceleration, it means that it is to be speeding up. So bumibilis siya in Tagalog. So in Filipino, when you say deceleration, it is bumabagal. So in Filipino, bumabagal pag sinabi nating deceleration. Okay, so suppose that in the question, what is being asked is to be, for example, what is to be the deceleration. So for pretend. And if your answer is to be this one here, so your deceleration should be positive 0.2222 meters per second squared. So deceleration. Because if you would now be including this negative symbol here, it is already redundant because you are already indicating the deceleration, and adding another negative symbol here would give you redundancy already. So it would be redundant. So with that, once again, if what is being asked in the question is to be the deceleration, drop the negative symbol already. Okay, so with that, once again, our acceleration is to be equal to negative 0.22. So our acceleration is to be equal to negative 0.2222 meters per second squared. Okay, so moving forward, so I would just be erasing this. And let us now proceed with the next question. So it is said here that what is the ball's velocity at a distance of 30 meters? So let's say that considering this already, so I will just be erasing this part. And let's say that your ball has traveled this much. So if your ball has traveled by that much, it means that, of course, your distance is now to be equal to 30 meters. So that is now to be your x, I should say. So x is now to be equal to 30 meters. So what is to be indicated in the problem is to be its final velocity at a distance of 30 meters. Okay, so with that, guys, once again, that what we are solving for here is now to be the final velocity. So with that, let us now check once again for this particular equations here for us to know what equation that we would be using. So once again, we cannot make use of this one here because we do not know the time. So we do not know the time here because of course it is not 6 seconds anymore because the distance is now, has now changed. So with that, going back here, so once again, we cannot make use of this and for this because all of them have their own times, and in this equation, VF is not included in the equation. So that leaves us with this particular equation. So we have VF squared, so that is to be the one that we will be solving for. And we also have VI. So for your VI, that is to be the initial velocity, so that is to be given. So your acceleration, we have already solved for this, and as for x, that is already given. Okay, so rewriting that equation, so VF squared is equal to VI squared plus twice the acceleration times your distance. Okay, so with that, so for your VF squared, so VF squared is equal to, so substituting known values, so VI, so 4 meters per second squared plus twice the acceleration. So acceleration is once again negative 0.22. So negative 0.2222 meters per second squared times your distance x, so times 30. Okay, so with that, our VF is now to be equal to, so I would just be getting the square root of both sides for my VF2. For the exponent 2 here to cancel out. So with that, looking at the equation, looking at the calculator to your left, so this is now to be equal to, so the square root of 4 squared plus 2 times negative 0.2222 times 30. Okay, so with that, the final velocity here is to be positive negative 1.6334 meters per second. Our answer here should be the one positive. Okay, so our answer here is the one that is now to be positive. So with that, our VF here is to be equal to 1.6334 meters per second. Okay, so for our last problem here for letter C, so how long will it take the ball to travel to attain a velocity of 40 meters per second? So as you can see, for your VI, that is now to be equal to 4 meters per second. And your VF should be 40 meters per second. However, your acceleration is actually a negative. So, a negative value. So, with that, guys, your acceleration is, once again, negative 0.222. And it means that your ball is actually slowing down. So, with that, if your initial velocity is now to be 4 meters per second and it is now to be slowing down, it means that it will never attain this velocity unless another external factor is to be applied to your system. So let's say that it was kicked for another time, so that is now just to be the way for it to attain 40 meters per second. So here, in letter C, so for letter C, the answer there is never. So it will never attain 40 meters per second speed because once again, for your initial velocity of 4 meters per second, the acceleration is to be decreasing. Okay, so there. Okay, so let us have another, rather easy example. So in this problem, a car starting from rest moves with constant acceleration. So after 5 seconds, the velocity is now 15 meters per second. So we would be computing for the following. So we would be computing for the acceleration, the distance traveled after 10 seconds, the time it took to travel 100 meters, and its velocity after traveling 50 meters. Okay, so with that, so it is said here in the problem that the car started from rest. So it means that its initial velocity is to be equal to 0 kilometers per hour or meters per second. So 0 meters per second. And after traveling for a while, of course, it would be accelerating for it to move. So its acceleration is to be constant throughout the motion. Okay, so with that, after 5 seconds, it is said here that the velocity is now to be 15 meters per second. So once again, after 5 seconds. So you would now be computing for the acceleration. So we can say that the final velocity is to be equal to the initial velocity plus the acceleration or the rate of change times time. So the initial plus the rate of change, of course, times time. So with that, our VF, so our VF is now to be equal to 15 meters per second. So this is now to be equal to our VI, and our VI, once again, is to be starting from rest. So that is now to be equal to 0 plus what is now to be the acceleration. So the acceleration is now to be equal to, well, we do not know that yet. So actually, that is to be the one that we are solving for right now, times, of course, the time. So the time it took for it to arrive, to have a velocity of 15 meters per second is to be 5 seconds as indicated in the problem. So 5 seconds. So with that, so solving for your value for the acceleration, that is basically equal to 15 divided by 5. So with that, our acceleration is to be 3 meters per second squared. So once again, for our acceleration A, so A, acceleration is to be equal to 3 meters per second squared. Okay, so we have already answered for this. Okay, second question. So what is to be the distance traveled after 10 seconds? So we can now make use of any of these formulas here. So we can make use of, let's say, I think I want to use this equation here. Since for the value for VI, that remains to be 0. So for the acceleration, we have already solved for this. And as for time, I think that was to be the one given in the problem. So where was that? So time after 10 seconds. Okay, so with that, once again, the value for our x is to be equal to VIT plus 1/2 AT squared. So x after 10 seconds, so this is not to be equal to VIT plus AT squared divided by 2. Okay, so with that, the value for x is to be equal to, so we do not know that yet, and for VI, this is to be 0 plus AT squared. So for our acceleration, that is to be 3 meters per square, 3 meters per square second. So 3 meters per second squared times time, and that is now to be equal to 10 seconds divided by 2. So with that, the value for x is now to be equal to, looking at the calculator to your left, so 3 times 10 divided by 2. So our answer here, squared. So this should be squared. So 3 times 10 squared divided by 2. So our answer here is now to be equal to 150 meters. So this is now to be our answer. Okay, so with that, our answer for letter B. So x is now to be equal to 150 meters. Okay, so there. Okay, so for letter C, what is now to be the time it took to travel 100 meters? So for C, what is to be the time for x to be equal to 100 meters? So I will be making use of the same formula because, well, I like to use it. So x is equal to the initial velocity times time plus AT squared divided by 2. Okay, so for the value for x, so the value for your x is now to be equal to 100 meters. So 100 meters is equal to, so our VI once again is to be 0. So 0 plus AT squared, so our A is to be 3 meters per second squared. And for the time, that is now to be equal to time, of course. So that is to be the one unknown divided by 2. So solving for t, take note that your t is to be squared. So it means that your answer is either positive or negative. However, we cannot have an answer to be in negative because we cannot have a negative time. So with that, so 100 meters times 2 divided by 3 square root. So our answer here is to be 8.165 seconds. So if we are to use shift solve method, so 100 is equal to 0 plus 3 times x squared divided by 2. So our answer here is to be 8.165. So this is to be correct. Okay, so with that, our answer for C is to be 8.165 seconds. Okay, so how about for letter D? So for letter D, so in D, what is to be its velocity after 50 meters? Okay, so with that, going back to this equation, so we cannot make use of this equation because we do not know the value of our time. So we cannot make use of this. So once again, VF is to be the one unknown. So if VF is to be the one unknown, so we can either make use of that or let's say make use of this. However, if we are to make use of this, we cannot make use of it directly because the one that is to be given in the problem is to be the distance. So we would be making use, we would be searching for a formula that in terms of distance would give us an answer in velocity. So with that, dapat merong x yung formula, meron ding VF. So with that guys, we can actually make use of this equation here or this equation here because we have of course your x and your VF. X and VF, and we already know the values of our VI, our A, our A. However, guys, we cannot make use of this once again because we do not know the time. So, hindi pala pwede to, hindi pala pwede. Kasi hindi natin alam yung time. So, with that, let us just make use of this equation here. Kasi alam naman natin lahat ng mga unknowns dito. Okay, so with that, so VF squared is equal to VI squared plus 2AX. So our VF squared is to be our V after 50 meters. So with that, so VF squared is equal to VI squared, and our VI once again is to be equal to 0. So 0 plus, so what is to be 2AX? So 2 times acceleration. So our acceleration is to be 3 meters per second squared. Times the value for our x. So the value for our x is to be 50 meters. So 50 meters. So with that, our VF is now to be equal to, so just get the square of both sides of the equation for us to get rid of the exponent 2. So with that, looking at the calculator to your left, so 2 times 30 times 50. So our answer here is to be 54.77. So 54.77 meters per second. So if you would be getting the square root of a certain answer, your answer would be positive or negative. However, our answer here would be positive because our acceleration is to be positive, and thus from 0, it must go up kasi nga bumibilis siya. So kapag naging negative to, edi umatras na ngayon yung sasakyan mo kasi nga negative na siya. It means that if your velocity is to be negative, its motion is now to be going to the left. So this should be positive. Okay, so with that, of course, our answer for letter D is to be that one.